Good evening. In this video, we are going to quickly go through in total 23 definitions from the Elements Book 1. Okay. So let's start. We have definition 1 here. A point is that which has no part. It's pretty clear. So let's assume this is a point, point A. It has no length, no breadth, and absolutely no area. Just a point here. And for definition 2, we have a line is breadthless length. So which means, for example, this is a line, it has no breadth, the breadth is 0. But it has a length, for example, L1, and no area. But interestingly, Euclid in the Elements, he had never classified different types of lines. So in his terminology, a line, the definition of a line can be straight, can be curved, or can be mixed, or can be pretty complex, whatever it looks like. If you are interested in the classification, please refer to another ancient Greek mathematician called Geminus. I think he had 2 different types of classification of lines, which is pretty interesting. And let's go to definition 3. The extremities of a line are points. So let's assume we have a line here. It is curved. And we randomly pick up a point here on the line. And we are trying to go to 2 directions separately. And at the end, when we reach the extremity, we will end up at 2 different points like A and B. And let's go to definition 4. A straight line is a line which lies evenly with the points on itself. I think the definition of a straight line by Euclid is pretty straightforward as a straight line. But if you are interested in the definition, there are also many famous definitions by other mathematicians like Proclus, Leibniz, and Legendre. Let's move to definition 5. So a surface is that which has length and breadth only. So let's assume this is surface. It can have a length L and have a breadth, let's say W, but it has no height. So a surface can have a specific area, but it can never have the volume. It is pretty similar to definition 2 here, definition 5 and 2. Euclid has also not classified the different types of a surface. So when he mentioned surface in his book, it can be something like a plane surface or a curved surface here, or very complex, or the combination of them, what shape it looks like doesn't matter. And let's move to definition 6. So the definition 6 is pretty similar to definition 3 here. It says that the extremities of a surface are lines. So like here, the extremities of a line are points. If we reach the end of the surface, we will end up at different lines here, L1 and L2, things like that. And definition 7 is, I believe, similar to definition 4. This defines a straight line, and definition 7 defines a plane surface. So a plane surface is a surface which lies evenly with the straight lines on itself. And very similarly to this, there are also other famous definition of a plane surface. For example, the definition by Crow and Fourier and other mathematicians. If you are interested, just refer to these kind of topics. And let's go to definition 8. Oh, we put definition 8 and 9 together. So definition 8 says a plane angle. Plane angle is the inclination to one another of 2 lines in a plane which meet one another and do not lie in a straight line. So please remember that in definition 8, we define what a plane angle is. So for example, alpha is a plane angle. The two lines that making this angle, they can be curved or straight or whatever it's like. They are just lines, but in Euclid definition, they are not limited to straight lines. Just recall this definition 2 of lines. In his definition, a line can be straight, curved, or anything else. And we move to definition 9. It says, when the lines containing the angle are straight, the angle is called rectilinear. So in definition 9, we limited the type of the lines here to be straight. So these are two straight lines, and the angle here is called a rectilinear. So we can say that, let's just write the alpha prime. So the rectilinear angle is belonging to a plane angle here. And let's talk about definition 10 to 12. They are talking about different types of rectilinears. So first of all, definition 10, when a straight line set up on a straight line makes the adjacent angles equal to another. Each of the equal angles is right, and the straight line standing on the other is called a perpendicular to that on which it stands. The definition is really long, but it is clear. So let's say we have a line L here and another line L2. The adjacent angle between them, let's say, is alpha 2 here. So we say it's a right angle, and line L and line L2 are perpendicular to each other here. And definition 11 and 12 defines an obtuse angle and an acute angle. So it says an obtuse angle is an angle greater than a right angle. For example, alpha 3, it is greater than a right angle here, so it is called an obtuse angle. And in terms of an acute angle, it is very similar definition, just the acute angle is less than the right angle here. For example, alpha 1. So we have alpha 1 is less than alpha 2, less than alpha 3, which means acute angle is less than a right angle, is less than an obtuse angle. So I think we have basically finished definitions 1 to definition 12, and we have actually covered over half of the definitions. And let's just take a break, and the other half is coming soon. Welcome back. So we are going to talk about the second half of the 23 definitions from the Elements Book 1. Okay? So at first, let's talk about definitions 13 and 14. So definition 13 says a boundary is that which is an extremity of anything. Let's say this is anything, and the extremity, this, is so-called the boundary. So this is the boundary. And 14 says that a figure is that which is contained by any boundary or boundaries. So if this is a boundary, it contains this part, it is called a figure. Okay, it's pretty straightforward. And then let's go to definition 15 to 18. All of them are talking about some concepts about circle. Okay, so definition 15 is a little bit long. A circle is a plane figure. Remember what a figure is. It's a plane figure contained by one line such that all the straight lines falling upon it from one point among those lines within the figure are equal to one another. It's long, but don't be scared by it. Let's try to understand what Euclid tries to tell us. Okay, so it says a plane figure and contained one line. One line, remember in the definitions, when Euclid says a line, it is not by default a straight line, it can be curved. So this is the so-called one line. And it says all straight lines falling upon it from one point. Let's say this is the so-called one point. So all straight lines falling upon the one line here, like these, and they are absolutely infinite of such kind of lines, and they are equal to one another. So we have them, they are equal and they have the same length, for example L, things like that. They are equal. And this is the definition of a circle. So the circle is this figure. Okay, remember what figure is here. And definition 16, let me check. Oh, it defines this point. The one point we have talked in definition 15. So this one point is so-called the center of the circle. Pretty clear definition. And definition 17 talks about the diameter. Okay, so a diameter of the circle is any straight line drawn through the center, through it, and terminated in both directions by the circumference of the circle. Okay, so we draw a line, straight line through this point, and it is terminated by the circumference here. Let's assume it is terminated by point A and point B. So AB is the diameter of this circle. And the definition says such a straight line also bisects the circle. So we can see the upper half here and the lower half, they are bisected by this diameter and they are equal to each other. I would like to say something that the terminology circumference, I think it is more or less a little bit weird because circumference has never been defined in the elements, but in definition 17 it is directly used. So I don't know why, but let's say the circumference is just this line, or let's say the circumference is the boundary of this circle, the boundary. Okay. Now let's move to definition 18. It defines that a semicircle is a figure contained by the diameter, see this is the diameter, and the circumference cut off by it. So this and these are the circumference cut by this diameter. So these two components contain the figure here is a so-called semicircle. And it also defines that the center of the semicircle is exactly the same as the center of the circle, which is point O. It is both the center of the circle and the center of this semicircle and this semicircle. Okay, so we have finished some definitions about the circle. Let's move to definition 19. So, okay, definition 19 is talking about rectilinear figures. The rectilinear figures are those which are contained by straight lines. Remember straight. So this is absolutely not a rectilinear figure because it contains curved boundary. Three pretty straightforward definitions. So a trilateral figure being those contained by three we can see these 3 straight lines, so it is trilateral. And if there are 4 straight lines like these, it is a quadrilateral. And if there are more than 4 straight lines, it is called a multilateral. But I would like to say that Euclid in this book has never emphasized or never declared that the multilateral must be convex. So I believe this is also a possible multilateral defined by Euclid. Okay, and then let's move to definition 20 and 21. They are defining some specific triangles respect to side and angle. Okay, so definition 20 says that an equilateral triangle is that which has its 3 sides equal. You can see side 1 equals to side 2 equals to side 3, so it is a equilateral triangle. And if it has 2 of its sides equal alone means they are equal, but they are not equal to the 3rd side. So this is so-called an isosceles triangle. And if 3 sides are not equal to one another, they are all unequal, it is called a scalene triangle here. Let's move to definition 21. 21 classify triangles by their by angles. It sounds like a tongue twist, but okay. The right angle triangle is a triangle that contains 1 right angle. Okay, so the obtuse triangle is a triangle that contains 1 obtuse angle, and an acute angled triangle is that triangle that contains 3 acute angles. Okay, let's finish it. And in definition 22, we have defined some specific quadrilaterals. So we will check them one by one. At first, we have a so-called square. So a square is the quadrilateral that is both equilateral and right angled, which means the 4 sides are equal to each other and it has 4 right angles. And then we have oblong. It is not equilateral. You can see this side is not equal to this side, but it is right angled. And we have rhombus. It is equilateral but not right angled. And we have rhomboid, which is pretty interesting because opposite sides are equal and the opposite angles are equal, but it is neither equilateral nor right angled. And as for those other quadrilaterals, we call them trapezia. Okay, so we have finished the definition 22. Let's move to the final definition 23. 23 talks about the parallel lines. So the parallel straight lines are straight lines which be in the same plane. Okay, so at first they have to be in the same plane and being produced indefinitely in both directions, which means we can extend them to infinity in both sides. For example, this side to infinity and this side also to infinity, both sides, but both directions, sorry, and they do not meet one another in both directions. So they will, let's say we extend both, they will never, like this, never meet with one another. I think it's pretty clear definition. So we have finished all those 23 definitions of book 1, and in the next video we are going to explore the 5 very famous postulates And thanks for watching. Have a good day.